Notes 12a. Functions and relations. Objective. I can determine if a relation is a function or not. Essential question. How do I determine if a relation is a function? While you're filling out this foldable and watching this video, also join the Pear Deck and contribute to the slides. Ask questions whenever needed. Vocabulary. Function. A special relation where each value in the domain is paired with only one value in the range. Relation. An association or significant connections between multiple things. Ordered pair. X does not repeat. Y is a function of X. 2, 1, 1, 0, 0, negative 1, negative 1, negative 2. On this one, y is not a function of x. 2, negative 5, 1, negative 4, 0, negative 3, 2, negative 2. It's because of these points right here, they map to two different y's. It can't do that for it to be a function. So using those definitions, is y a function of x for this one true or false? And how about the next one? You should have gotten one true and one false for these. See if you can identify why. Okay, let's look at tables. X cannot repeat for it to be a function. So on this one, y is a function of x. This one, y is not a function of x. So notice that each x maps to only one y. On this one, notice that that 3 goes to 1 and 4. The 4 goes to 2 and 5. So 3 goes to 1 and 4, and then 4 goes to 2 and 5. You can't have that, so that's why it's not a function. These are relations, but they're not functions. So, true or false, this table represents a function. Think about why or why not. Okay, let's look at mapping diagrams. The x cannot repeat. Okay, so here's where y is a function. This one, y is not a function of x. So this one knows that the x's all just go to one y value. Now, 2 of them go to a, but it's okay if 2 x's go to the same y. It's just that an x can't go to 2 different y's. Y is not a function of x on this one. You see this? The 1 goes to 2 different y's, and the 3 goes to 2 different y's there. True or false? Y is a function of x. Is this a function? Why or why not? Graph passes the vertical line test. Y is a function of x. It only passes through once if you make a vertical line anywhere on the graph. On this one, we found one counterexample to show that it's not a function. We drew a vertical line and we found that it goes through it twice there. You can't have that. If it's 2, 3, 4, an unlimited amount of times, it can't be a function. So the vertical line, x equals some number, that is not a function. This one's a function right here. How about this one? Y is a function of x. Is this a function? True or false? On this slide, draw a relation that is not a function on this graph. What is something that would fail the vertical line test? Draw it right here. Explore this slide. Drag the icons over relations that are functions. There could be more than 5 that are functions. Discrete versus continuous. What do you think the word continuous means? Continuous just means that it keeps going. No breaks or gaps. So like a solid curve, that is continuous. It's measured. Discrete is counting. And it's just a set of points. So here's a discrete graph. Here is a contiguous graph. On this slide, go ahead and drag the icons over continuous functions. Domain versus range. What variable goes with domain? It's the x value. The range goes with y, or they might say f of x. Which function has a domain of 1, 2, 3, 4, 5, 6? Circle the correct answer. So which one has x values of these right here? Exactly these right here. Drag the lines to match the image to the answer. Which words go with x? Which words go with y? Okay, so domain goes with x. Independent goes with x. Range goes with y. Y variable goes with y. X variable goes with x. Increasing, decreasing goes with x. Dependent goes with y. Input goes with x. Output goes with y. Down up goes with y. Left right goes with x, and then f of x goes with y. Domain is independent, it's x, the input. Y is dependent, output, range. How well do you understand what we just covered? Choose which one that you agree with. Do you know it like so well you could explain it to someone, or are you not quite sure where to start yet? Let's put it all together on this example. So we have -1, 1, 0, 0, 2, 1, 2, -2, and 3, 4. Remember, x comes first and then y. So let's label those. So we have x, y, so we're going to label those numbers. Okay, so here's our table. Okay, let's go ahead and graph it. Let's say that each increment is 1. So you have -1, 1. 0, 0, 2, 1, 2, negative 2, and 3, 4. Okay, then we write the numbers right here. Least to greatest for these. So negative 1 maps to 1. 0 maps to 0. 2 maps to negative 2 and 1. And the 3 maps to 4. Okay, so this relation is discrete. It's counted points or set. Is it a function? No. Why? Well, if you look at the graph, it fails vertical line test right here. We just say VLT for short. We could also say for the mapping, the 2 goes to 2 different y values here. So the independent variable goes to negative 2 and 1, 2 dependent variables. On the last slide, write your summary. Explain the difference between a relation that is a function and a relation that is not a function. One more thing. If you have a graph and it passes both the horizontal line test and the vertical line test, that function is one-to-one. So those are special functions. They can only be odd degrees.